Hello, my name is Sumanjeet and I am a contributor at PLDG and currently working at lip2p. It's been an exciting journey for me. I have collaborated with many of the developers and talked to many of the maintainers in lip2p. And using their guidance, I have created a PubSub example in Python lip2p using GossipSub. And in this video, I am going to show you exactly what I have created. The contents of today's videos are as follows. First one is PubSub in lib2p, then GossipSub, then PubSub example demo. This is a quick demo of how the PubSub example is working. Then I am going to show you the PubSub example code, how it is structured and how the execution of the code happens. And there is something for the future contributors. And lastly, how can anyone join our community? So now PubSub in lib2p. PubSub stands for Publish Subscribe. It is a messaging pattern in lib2p that allows decentralized message propagation. That means messages are going to propagate, but it happens in a decentralized manner. There are two terms, publishers and subscribers. So publishers are those nodes who sends message to a specific topic, and the publishers don't know exactly about the subscribers. The subscribers are those nodes or people who shows their interest in a specific topic that they want to receive the message of that topic, and they receive that message without any direct connection with the publishers. Unlike traditional client-server models, PubSub in lib2p works in a peer-to-peer manner. So this is a traditional centralized PubSub where all the clients gets connected to a central server, and then uh, any client can get subscribed to a particular topic, and when anyone in the PubSub sends a message or publishes a message to a particular topic, then all of the clients who have subscribed to that topic will receive their messages. But in in, in PubSub, in lib2p, it happens in a decentralized manner. So every other node is connected with some other nodes, and the messages are going to transfer via these nodes. So there is no central server. It is a decentralized PubSub. Nodes relay message. So here, whenever a node publishes a message, then that message gets to their nearest neighbors or nearest nodes, and these nodes relates the message to other nodes, and in this way, the messages are propagated in a decentralized PubSub. It enables a scalable and robust communication. So it is a very scalable method of PubSub, and it is used by IPFS and some of the blockchain applications. So now let's talk about the Gossip Sub. So the Gossip Sub is nothing but an advanced PubSub implementations in lib2p. There are other implementations also, that is the PubSub, but the Gossip Sub is more advanced. The Gossip Sub enhances the message propagation using an efficient gossip-based protocol. So what happens is that in a large network, a node randomly selects some of the other nodes and then shares the message with them. The other nodes also select some of the other nodes, and then they also share the message with them. In this way, one node propagates the message to all over the network. There are two ways of message propagation. The first one is direct message propagation. In this way, the uh, no- the node shares all of their message with their selected nearby nodes. But in the other one, only the message IDs are being shared with the nearby selected nodes to optimize the bandwidth. So the benefits of the GossipSub over the other implementations are: GossipSub is highly scalable. It reduces the bandwidth usage as compared to other implementations like PubSub-based PubSub. GossipSub is highly resilient. So GossipSub ensures messages reach even disconnected or transiently connected nodes. So GossipSub ensures that if a node gets connected and then disconnected and it gets reconnected, then the after getting reconnected, the GossipSub tries to synchronize the messages with the other nodes. So in this way, transiently connected nodes also get all of the messages. And GossipSub is highly secure. The features like peer scoring and message validations help GossipSub to reduce spam and some of the attacks. So now the next one is the demo part, and I am really excited to show you what I have created and how it is working. So let's open a new terminal. I am using my Warp terminal, and let's open the file. And you can easily open it using Python pubsub.py. So you can see that the application is now running and the node, the key pair is being created, and then the node is subscribed to the topic PubSub chat. The application is running on port 47757 in my operating system. It will be different on your system as it is randomly being chosen. This is the peer ID of the host. This is the address on which the host is listening, and yes, so this is the multi-address using which other hosts can get connected to this host. And I have created this simple script using which when you use this script in other terminal, you will just it will just create another host and directly dial to this host, and it will basically try to get connected to this host. Let's try it out. So I paste this script in this other terminal. So here also a key pair gets created, and it is also subscribed to the same topic. It is running on this port. It has this peer ID and everything is normal. Now it is logging that it is connected to the peer disk. So you can see that this is the peer ID of this node, and these two nodes are now connected. So let's connect one more node to this one. As you can see that these two, both of them are subscribed to the same topic, that is PubSub chat. So now if I send them a hi message, then this will receive that hi message. And if I write hello, the this terminal will also receive the hello message. And now let's try something different. That what will happen if a third terminal, uh, that a third node is being turned on and it is subscribed to some of the other topics, then what will happen? So let's say I copy the multi address of this one. Oh, sorry, this one, and paste it here. And now I am going to subscribe this to another topic, let's say lib2p. So this one is running a host which, and this host is subscribed to a topic lib2p. Let's create another host which is also subscribed to the same lib2p topic. So these two nodes are connected to this node, and these two are subscribed to the libp2p topic. Let's say I am on libp2p. I am also glad. Yeah. So we can say that these two nodes can uh, transfer their messages to each other because they are subscribed to the same topic, and these two nodes are talking with each other because they are subscribed to some different topic. So topics are very important in a publisher subscriber model, and that's for this demo. After the quick demo of the PubSub example, now let us look at the codes of the PubSub example and try to understand the basic working and the basic structure of the PubSub. So here is the file and here is all of the code of the PubSub example. I have imported these libraries which are used to run the application, and I have set the logger which is used to log the internal details, and it helps in debugging. This is the default chat topic. So this is the topic to which our host will get subscribed if none of the topics are given. This is the PubSub Protocol ID. Here we are creating a key pair for our node. Here we are creating some of the protocols for secure communication. So the messages will be communicated in encrypted manner. So these are some of the functions which we will use, and when anyone runs the python pubsub.py, then the main function will get executed, and inside main function here is a description which gives a brief idea of what the application is. I have used a parser which is used to parse all of the given arguments. Here are four arguments which can be passed. So the first one is the topic. So this is the topic name to subscribe. So the host will get subscribed to this topic. And if the topics were not given, then it will try to subscribe to the default topic. The second one is the destination. So this is basically the multi-address of another host, and this host will get try to get connected to that another host. The third one is the port. So this is the port to listen on. So our application will start listening on this port on our operating system. This is the verbose, and verbose is used to set the debugging level, set the logger level to the debug, and it is an some of the asynchronous functions are used in this application. So we have to use trio to run that in asynchronous functions. So the asynchronous function so name is run, and these are the arguments which are being passed to the run function. So here is the run function, and we have passed the topic, destination, and port. So this is just a constant, and we are basically initializing the network settings. So this is the location where the application will listen, and if port is not provided or the provided port is 0, then it will find a free port on our operating system and try to run the application on that free port. This is basically a multi-address which is being created using the localhost IP and the port number. So using this multi-address, anyone can get connected to this node. Here we are creating a new libp2p host. So we are using the new host function for this, and we are passing the key pair, the multiplexer, and some of the security options, and the host will get created. This is just a basic login for this, and here we are creating a gossip sub object with some of the different parameters, and some of these can be ignored as these some of them have some default values which I have overridden here for the optimized testing. But yes, the gossip sub is running using the gossip sub protocol ID. This is important, we have to pass it. Now we are creating a PubSub object using the host object and the gossip sub object we have created earlier. We are creating a trio event which is used to signal the trio that we want to cancel some of the asynchronous tasks. Now we are running the host using this function host.run, and we want the host to listen on this multi-address listen address which we have created earlier, this one. And here we are now some of the we are logging some of the details here. And now we are now creating two background services. First one is PubSub, and inside PubSub we are creating one more background service, that is GossipSub. It is just another login, and then we are waiting for the PubSub to get ready. After that, we will subscribe our node to the particular topic the user has provided, or we will subscribe it to the default topic, which is chat PubSub or PubSub chat. So if the user has not provided any destination, then it will log this one. It will log this, run the script in another console with Python pubsub.py -d, and this is the multi-address of this port. So if no destination is provided, then this will log out this thing, and using this script, any uh, any other node can get connected to this node. We can basically just run this script in another node, and this will be the multi-address, and the other node will get connected to this node. Here we are creating three of the child processes inside the host.run, and the first child process is to monitor all of the peers which are connected to this host, and then um, this host will get subscribed to all of the topics. This is only for the demonstration I have done this. This will act as a server. Basically, if anyone is not providing a destination, then it will just start to wait for some of the other clients to get and join this host. And here we are just starting one, that is receive loop inside nursery. So basically we are just starting a child process which will be used to receive the messages from the other nodes, and we are passing the subscription and termination event. Then we are starting another child process which is publish loop. It is used to publish the message to other nodes, and if the user has provided a destination, then we will use that destination and create a multi-address out of it. Then using that multi-address, we will create the info of it. That means we will get information about that peer using this multi-address, and after this we will just log some of these things, which is basically a script which is used to which is used for any other host to get connected to this host. And after getting this information about other host of which the destination is provided, we will try that our host will get connected to that host of which the destination is provided here using await host.connect. If the host gets connected to that another host, then it will log that connected to peer and the peer ID of that peer of that another peer. And if the debugging is enabled, yani if dash dash verbose is passed as an argument, then it will wait for 1 second so that everything will get settled and PubSub is actually get connected. Then it will just look out for all the peers in the network and just log the details about it. Yes, basically the peer protocols. It will log out about the peer protocols. And here we are also creating two child processes. The first one is the receive loop to receive the message from the network, and the second one is the publish loop to publish the message to the network. And if anything goes wrong, then there is a logger.exception. It will raise an exception that failed to connect to peer, and then it will just close everything. The main purpose of this using this child process is that if anything goes wrong in these child processes, everything will be terminated and a termination event will be sent, and every child process running inside the host.run will get terminated, and the host.run also get terminated, and all of the resources will get freed up. And now let us look at some of the functions that how actually these are working. The first one is receive loop function. So we are receiving a subscription and termination event. So while there is no termination event, then it will constantly try and await for getting any messages from that subscription, and if it gets any message, then it will first log it and then it will just print it. And if anything goes wrong, it will raise an exception here. The second one is the publish loop. In this publish loop, it is just logging and then printing something. And while the termination event is not set, then it will just run a new thread and try to get input from the user, and it is basically the input is taken from another thread so that the input is not being blocked. And if the message is quit, then the termination event will be set to quit and all the trio events will get cancelled and terminated. And if the message is not quit and it's a general message, then the PubSub will publish that message to the a specific topic which we have received. So basically, the PubSub will publish a message on a particular topic. This is find free port function. This function is used to find a free port on our operating system so that the application can listen on that free port. This is monitor peer topics. So it just checks for all the peers which are connected to that PubSub. So if a host is connected to three of the peers, then it will look for all of the peers one by one and try to find out to which topic the peers are subscribed to, and it will get subscribed to that topic automatically. So this is how the whole PubSub example is working. Now let's talk about the people who wish to contribute to the lib2p and get started with it. So I have collected some of the resources which might help those people to get started with the libp2p. So the first one is the docs of the libp2p. Here is the link of the docs, and this is the docs of the libp2p. And in the about section, you can find all of the information which you will need to get started with the libp2p. So it basically in the starting covers what is libp2p, who uses the libp2p, and then these are the some of the fundamental things: the transport, secure communication, stream multiplexing, everything. All of the libp2p things you can find it here, and you can read about it using this website. And after reading about it, you can go to the guides and try to run a node in your local system. It has all the documentation of how you can just clone it and then install and run these applications, these nodes basically, in Golang, in JavaScript, and in the Rust. Okay, and you can also read some of the blogs about it. So you get the idea how can you read about the docs. And after the docs, you can go through the examples. So basically this is the link of the example, and you will find the examples here. So you can also try out the examples and try to run it locally on your system and get familiar with the these codes, that how these codes are working internally, and you can try to run this. These are almost similar, so you will not face any difficulty while running it. So you can definitely check this out. It is a good starting point. And after that, these are aspects. So this is one of the most important things, because in the aspects you will find the detailed explanation of what is being used and which protocol is used and why it is used, just like discovery. So how the discovery works in the libp2p, you will get a detailed note about this, and you can find almost everything like the noise protocol, the multiplexer. So you can look at the noise protocol and every details about it. It has also the change logs, which version has which changes, and how the backward compatibility is there or not. So you will get everything about this. It is in very detailed manner. And after you have run the read this, you can definitely start to contribute at some of the things. And good the good place to start is the Universal Connectivity app. This is the link for it. You can go there, the Universal Connectivity app. Whether you are a JavaScript developer or a Go, Rust, or any developer, you can find something for you. Here you can see that in many languages the development is going on. This is the .NET peer development, and here also the Python peer development where I am working on currently, and here also, and so I don't remember the exact name, and I think some the name was. So basically it is here there are different peers for this Universal Connectivity app. This is the Go peer. You can read about it, that how it is working and what can you do with this. So it has everything. It has this these instructions using which you can just clone the application and run the application and test this out. And if you want to contribute to it, then the easiest way is to go through these Go peers or JavaScript peers, and these are fully functional. And using these examples, using the way it is created, you can create some of the more peers, and the Python one, the CPP one, and other peers are also in development. So you can basically contribute to it. You can find it here like .NET peer development. So you will find this. This is in currently development. and also the Python peer development where I am working. So you will find this. So basically you can contribute to this universal connectivity app in many languages easily. And the last one is the gossip sub. So gossip sub is also used in my in my PubSub example. So this is the code for the gossip sub, and here you can see there is two protocols. There are two protocols, 1.0 and 1.1.0. So you can just carry on with the future versions of the mesh hub and also try to bring the you can also implement the future versions of it, ensuring that the backward compatibility will not break. So you can read about it, what's the new in the new gossip of implementations, and you can just try to bring that feature here. This is also a good place to contribute. And so overall, I think you can just read the docs, go through the examples, and then through to the specs. And the best way to get started will be the universal connectivity app. It will be an easy one. You can also join the lip2p community by going through these links. So these links is for the community discussion. These links for the implementers, those who are using the lip2p to implement something. So, and this is the Telegram ID. You can also join here, and this is the X or formerly Twitter. So you can join these communities and get help, whether you want to contribute to this application or you wish to just see the future development. You are always welcome in these communities. You can join these communities very easily. I hope this video will be useful for you, and thank you for watching this video.